In this video, we'll talk about a common error that folks make in L'Hopital's questions. So I want to look at an example in which we have the limit as x approaches 0 from the right of ln of x over e to the 2x minus 1. And these are all the steps in a particular solution. And the question is, what's the error in this above argument? So I want to give you first 1 minute to look this over and see if you can identify, well, where's the error? 4, 3, 2, 1, pause it and try this question for about a minute. Alrighty, so hopefully you did that. Hopefully you paused it for about a minute to think through where the error or errors may be. So let's talk about it. So this question, there is an error, and the error is in the very first step where they use L'Hopital's rule. So it's at that step right there. And it turns out that there's something wrong about them using L'Hopital's. So if we take the limit as x approaches 0 from the right of ln of x over e to the 2x minus 1, if we plug in as a first step, I don't just want to plug in 0 straight up on the top, because that would give me ln of 0, which is undefined. So I'm going to be more careful on the top. X is approaching 0 from the right, so I'm going to write ln of 0 with a little plus sign to indicate that x is a little bigger than 0. On the bottom, I'm just going to plug in 0 straight up. I'll have e to the 0 minus 1. It'll turn out that'll just be just fine for what I'm trying to say. So on the top, ln of 0 with a little plus sign, that's negative infinity. As x gets really, really close to 0 from the right, ln of x goes to negative infinity. And on the bottom, we'll have 1 minus 1, which is 0. So negative infinity over 0, this is not one of the forms we can use L'Hopital's on. This is not a form we can use LH, L'Hopital's rule, on. Remember, we can only use L'Hopital's rule if we see something of the form 0 over 0, or plus or minus infinity over plus or minus infinity. But that's not what this is. So they made an error in that first step. And then after that error, the things that they did were fine based on the fact that they had made the error. So after that first step, going to the next step, they just plugged in 0 with a little plus sign. So on the numerator would end up going to infinity there. On the bottom, there was no issue with just plugging 0 in, so that gave them 2 e to the 0. So overall, this was infinity divided by 2, which is infinity. So in the subsequent steps, there weren't additional errors. Of course, because they made an error in this first step, that means the overall what they did is wrong. So let's talk about how you would fix this. So what is the correct solution? So we had the limit as x approaches 0 from the right of ln of x over e to the 2x minus 1. But now we know what we're supposed to get when we plug in. When we plug in, we actually have negative infinity over, and now I'm going to be more careful in the denominator, because it's initially we wrote 0. Let me be more careful. And let me also write e to the 0 with a little plus minus 1. So this is going to be negative infinity over. Okay, so because this exponent is close to 0, but it's a little bigger than it, that'll make e to that power be a little bigger than 1. Because not just e to 0, it might be like e to the 0.001. So that's going to be a little bigger than 1. Okay, so that makes the whole denominator really close to 0, but a little bigger than it. All right, 0 with a little plus sign. Okay, so the whole fraction, I have a negative on the top, a positive number on the bottom. That's going to make a negative. So when I have a huge number on the top, ignoring the negative sign, a huge number divided by something really, really, really small on the bottom, that's going to be really, really huge. So it's definitely going to be some type of infinite thing. We already determined the sign, negative. So that would be the correct answer. It's actually negative infinity. Okay, so the key takeaway from this is we can only apply L'Hopital's rule if the limit has the form 0 over 0 or plus or minus infinity over plus or minus infinity. It can be really tempting when we first learn L'Hopital's rule to say like, oh, can't I just do it on every single limit? But we have to be careful. We can't. We can't use it on every single limit. It's got to have one of these forms for us to be able to apply it. All right, so let's do another example where we identify errors. So we have this argument here, and I want to give you a minute to try this one as well. 4, 3, 2, want to pause it for a minute, see if you can identify where the errors may be in this argument. Alrighty, so hopefully you did that. Hopefully paused it for about a minute to think through this. So we have this limit as x approaches 3 of x squared minus 9 over x squared minus 6x plus 9. In the first step, they did L'Hopital's rule. They took the derivative of the top, which is 2x, the derivative of the bottom, which was 2x minus 6. And then they did L'Hopital's again. So the derivative of this new top was 2. The derivative of that new bottom was 2. And then the 2 over 2 just becomes 1. So our limit just became 1. So if we look to this first step where they did L'Hopital's rule, this is okay. This is okay since the starting limit as x approaches 3 of x squared minus 9 over x squared minus 6x plus 9. If we were to plug 3 into this, this has the form 0 over 0. And that's something I can do L'Hopital's on. But the next step where they did L'Hopital's, this is not a form we can do L'Hopital's on. There's an error here. There's an error there. We can't use LH, L'Hopital's rule, on the limit as x approaches 3 of 2x over 2x minus 6. Since this has the form, if you plug 3 into this, the top is 6, the bottom is 0. But that's not a form I can use L'Hopital's on. This is not 0 over 0. It's not infinity over infinity. So how would we do something like this? Where you have 6 over 0, this is a non-zero on top and a 0 on the bottom. Remember, the way we do that is we do one-sided limits. We would take one-sided limits if we actually wanted to evaluate this. Okay, so I will leave that as an exercise to finish it. Mostly, I wanted to talk about what was wrong about this argument. In terms of our goals for this section, we finished goal 2, recognizing when L'Hopital's rule doesn't apply.